Server-side request forgery. Let's first gain an understanding about server-side request forgery. Server-side request forgery is a web security vulnerability that allows an attacker to trick a server-side application into sending requests to an unintended website. A common SSRF attack may cause the server to connect to internal-only services within the information of the organization. Additionally, they may be able to force the server to connect to arbitrary external systems, potentially exposing sensitive information such as authentication credentials. The target application may include functionality for importing data from a URL, publishing data to a URL, reading other tamperable data from a URL. The attacker modifies calls to this feature by delivering a complete different URL or altering URL construction, path traversal, etc. The server-side code recognizes the manipulated URL and attempts to read data from it when the manipulated request is sent to the server. By selecting target URLs, an attacker may be able to access data from services that are not immediately exposed to the internet. Let's look at an example where an attacker can extract cloud server metadata via SSRF cloud services such as AWS provide a REST interface at http:// and the following IP as shown on the screen, from which sensitive settings and in some cases authentication keys can be retrieved. NoSQL databases include MongoDB, provide REST interface over HTTP ports. Authentication may be deactivated if the database is intended for internal use only, allowing the data to be extracted. Let's now discuss the types of SSRF. There are three categories of SSRF vulnerabilities: basic, blind, and semi-blind SSRF vulnerability. Basic SSRF allows attackers to easily fetch data from any URL within the internal network of the target system. Blind SSRF doesn't provide information about the target service from the initial request, requiring tools like Burp Collaborator or DNS bin for confirmation. In semi-blind SSRF, the attacker partially controls input and output, being able to control the host and port but not the path. Let's further see how SSRF poses a threat to the organization. Impact of SSRF. SSRF vulnerabilities can pose a serious threat to the security of an organization's network. Here are some of the reasons why. Unauthorized access. A successful SSRF attack can lead to unauthorized access to data within the organization, either in the vulnerable application itself or on the other backend systems with which the application can communicate. This can have serious repercussions for an organization. Legal liabilities and reputational damage. An SSRF exploit that causes connections to external third-party systems might result in a malicious onward attacks that appear to originate from the organization hosting the vulnerable application. Legal liabilities and reputational damage could follow from this action. Exposure internal systems. SSRF vulnerabilities can expose internal or firewall systems which hackers can exploit to gain unauthorized access. Service discovery and port scanning. Attackers can use SSRF vulnerabilities to perform server discovery and port scanning, which can help them identify other vulnerabilities within the organization's stock network. Remote code execution. Under certain conditions, an SSRF vulnerability could allow an attacker to perform arbitrary command execution and lead to remote code execution. Practical. Server-side request forgery is a web security vulnerability that allows an attacker to trick a web server-side application and access the internal sources of a web application. Now that you know what SSRF is, let's see it in action. Head to the BWAP and select SSRF and click on Hack. The first step is to perform port scanning on internal network using RFI. By clicking on port scan, you can see that there is a file called SSRF1.txt that is scanning for ports like the following as shown on the screen, using the IP parameter from the script. Head to the RFI section and click on Hack. As we can see, it is using a language parameter. Now we will perform port scanning through RFI with the help of SSRF1.txt script. Copy the SSRF1.txt file and create a directory in Kali named evil, and inside it create SSRF1.txt file. Now host the file using Python by using the command sudo python 3-m http.server port number 80. The command will start an HTTP server on port 80. Type the command ifconfig to get the IP address of Kali. Now head towards the browser and modify the parameter language to the IP address of your Kali machine and the directory location of SSRF1.txt. Add in the IP parameter as it is a parameter which is loaded by the script for port scanning, and paste the localhost IP as we can scan the internal network. As you can see, port 22, 25, 80 and port 3306 are open on the vulnerable machine. We just performed SSRF through RFI on this vulnerable machine. The second step is to access resources on internal network using XXE. By clicking on access, you can see that there is a file called ssrf-2.txt which contains the XXE payload which is used to access the robots.txt file and heroes.xml file. Now let us see this in action. Select XXE from the drop-down and click on Hack. Start burp suite, intercept and turn on burst proxy from proxy. Click on any works button and send a request to repeater. Now copy and paste the first XSE payload and send the request. As you can see, we are viewing the contents of robots.txt file. Now copy and paste the second XXE payload to view the contents of heroes.xml file which contains the user and their passwords. Copy the base64 output and paste it in the decoder tab and select decode as base64. As you can see, we can access the internal files of the vulnerable machine. SSRF attacks prevention. Here are some of the fundamental methods for preventing server-side vulnerabilities. DNS whitelist domains. The simplest approach is to address SSRF is to whitelist any domain or address that the application accesses. Blacklisting and regex share the same problem in that someone will ultimately figure out how to attack them. Do not send raw responses, never communicate the server's raw response body to the client, requests from the client must be anticipated. Enforce URL schema, allow only URL schemas used by your application. If you see any other schema, ensure that they are available only from the component that needs them and not from anywhere else. Enable authentication on all services. Ensure that authentication is enabled on any service running within your network, even if not required. Services such as Memcached, Redis, and Mongo don't require authentication for typical operations, which means they might be abused. Sanitize and validate inputs. Never depend on user input, always sanitize any input sent to your application by the user. Remove unwanted characters and standardize input double quotes instead of single quotes. For example, after sanitization, validate the sanitized input to ensure nothing malicious passes through.